This again is a very becomes a very simple question if you draw the energy level diagrams. We have been given that the shortest wavelength line of Lyman series of hydrogen atom is X. We need to find out the wavelength of first line of Balmer series of hydrogen atom. So for this, let us draw the energy level diagram first. This is equal to n is equal to 1, this is n is equal to 2, and the gaps keep on reducing. That is, the gap between these layers keeps on reducing as we go higher. This is n is equal to 5. Now we know that this is equal to minus 13.6 electron volt, this is minus 3.4 electron volts, this is minus 1.51 electron volts. Now the shortest wavelength line of Lyman series. The Lyman series are all the lines ending at n is equal to 1. That is beginning at some excited state and coming down to n is equal to 1. These are the lines of Lyman series. Now the shortest wavelength line, we know that the energy of the transition is hc by lambda. Therefore the shortest wavelength line will correspond to the maximum energy transition. Now the maximum energy transition of the Lyman series is equal to the one coming from infinity to n is equal to 1. Now the energy of this state is minus 13.6 electron volts. Therefore the energy of this transition will be equal to 13.6 electron volts. Therefore we can write this hc upon x, this lambda is given to be x, is equal to 13.6 electron volts. Now the wavelength, we need to find out the wavelength of first line of Balmer series. Balmer series, now let us draw the diagram over here. The Balmer series consists of all lines which are ending at n is equal to 2, from infinity to 2, from n to 2, from 5 to 2, 4 to 2, 3 to 2, all the lines ending at n is equal to 2. These are the lines of the Balmer series. We need to find out the wavelength of first line. The first line of the Balmer series is this line. We need to find out the wavelength of this line of Balmer series. Now let us write the equation for this transition. For this transition, hc by lambda, let us this transition corresponds to one photon. The energy of that photon can be written to be hc by lambda. This is equal to 13.6 into z square, that is 1 square, into 1 upon n1 square minus 1 upon n2 square. This n1 is the lower orbital is written first, therefore 1 upon 2 square minus 1 upon 3 square. Now we need to find out this lambda, let this be lambda dash. Therefore we get 1 upon lambda dash is equal to 13.6 upon hc into 5 upon 36. Now we know that 13.6 upon hc is equal to 1 upon x. Therefore we can write 1 upon x over here. Therefore we get the value of lambda dash is equal to 36x upon 5. So final answer for the wavelength of first line of Balmer series in terms of the shortest wavelength line of Lyman series comes out to be equal to 36x upon 5.